October 2025. For the third time in human history, an interstellar object is on approach. This one different, brighter, and moving faster than anything ever cataloged. 3. I/Atlas, once a distant curiosity glinting beyond Saturn, has now crossed the orbit of Mars and is closing in on the inner system. What began as a faint speck on survey images has become the most closely monitored body in the sky. Every observatory on Earth is tracking it. Every space agency watching its trajectory minute by minute. At first, the numbers looked routine. A hyperbolic visitor, inbound at 56 kilometers per second, bound to swing past the sun and vanish forever. But by early October, the models began to drift. The expected curve tightened, the projected missed distance shrinking with each new update. Within a week, the probability corridor had narrowed so far that a new phrase appeared in NASA's internal log, potential Earth intersection zone. That alone was enough to send the Jet Propulsion Laboratory into round-the-clock recalculations. The Sentry Impact Risk software ran continuous Monte Carlo simulations, tens of thousands of orbital permutations each hour. Everyone ended the same way, a near path, uncomfortably near. If the new readings held, 3 I/Atlas would skim inside the lunar orbit within the month. The object's brightness told its own story. In early August, it shone at magnitude 10, barely visible through medium telescopes. By October 2, it had climbed to 6.2, the threshold of naked eye visibility. Yet there was no tail, no plume, no coma. Its spectrum remained unnervingly flat, a metallic gray reflectance curve inconsistent with any known cometary dust. The Pan-STARRS survey flagged the anomaly. The Minor Planet Center confirmed. For a body barely 10 kilometers wide, it was reflecting light as if it were polished. That detail caught the attention of one agency in particular, NASA's Planetary Defense Coordination Office. On October 4th, an urgent bulletin was issued to partner observatories. The order was simple: continuous tracking, optical and radar. Goldstone and Arecibo's successor array in Puerto Rico were tasked with pinging the object as soon as it crossed 0.1 AU. No one wanted another surprise like Oumuamua, only bigger, closer, and unpredictable. By October 6th, the first radar echoes came back, faint but coherent. Analysts expected a fuzzy reflection, the blurred return typical of tumbling rock. Instead, the signal came back sharp, consistent with a surface smoother than any natural asteroid. The Doppler spread was narrow, implying slow rotation. One full turn every 8.1 hours, clockwork regular. The signature pattern repeated exactly on the next ping. Meanwhile, the James Webb Space Telescope caught something stranger still. In the infrared, 3 I/Atlas glowed evenly across its surface. No hot spots, no cold shadow. Its thermal emission was nearly uniform, a feat impossible for an irregular sun-warmed rock. Dr. Elena Marovich, still leading Webb's Transient Object Division, summarized it in one line: "It looks as if the entire body is temperature regulated." Speculation rippled through the scientific community. Could it be encased in a carbon-rich shell? A crust of metallic glass? None of the standard explanations fit the observed emissivity ratio. And then came the course deviation. On October 8th, just after 0300 UTC, tracking stations in Hawaii and South Africa logged a measurable shift in its trajectory. Small but real. The delta V was on the order of 2 meters per second, enough to move the projected path tens of thousands of kilometers closer to Earth. Solar radiation pressure couldn't account for it. The vector was wrong. Something else had pushed it. Within hours, NASA's Deep Space Network confirmed the maneuver. The new flight path would bring 3 I/Atlas inside 300,000 kilometers, roughly 3/4 of the distance to the moon. Not an impact course, but far closer than any interstellar visitor has ever come. Across social media, the word impact began trending anyway. Amateur sky watchers posted blurred streaks and long exposure trails, claiming to see the object brightening each night. Official statements urged calm. There is no immediate threat. The object will pass safely. Yet, inside mission control rooms, no one was relaxed. The concern wasn't just proximity, it was what the light curves showed next. As 3 I/Atlas neared 0.2 AU, its brightness stopped following the inverse square law. Instead of increasing steadily with sunlight, it plateaued, then flared by 28% in under an hour, identical to the pulse recorded months earlier when it altered course beyond Jupiter. Once again, luminosity and motion changed together. By October 10th, Webb's near-infrared spectrographs detected a faint modulation in the glow, a rise and fall every 3.9 hours, perfectly periodic. The same rhythm found in July's thermal heartbeat had returned, only stronger, and now synchronized with the object's rotation. At this stage, the narrative split into two camps. The official brief: internal outgassing jets or subsurface vents producing thrust. The unofficial theory whispered in late-night channels: controlled maneuvering. In Pasadena, mission planners drafted contingency. If the object continued to drift earthward, a flyby window for direct observation would open between October 17th and 19th, just before perigee. Proposals flooded in for everything from high-altitude balloons to repurposed asteroid probes. Even the aging OSIRIS-REx team offered to redirect spare ground-based radar assets. But a simple truth hung over every meeting. No one knew what they were dealing with. 3I/Atlas had violated every known model of cometary behavior. It emitted heat from within, pulsed like a machine, changed course without an external cause, and now, against all statistical odds, was headed straight toward Earth's orbit. By mid-October, all major space agencies had converged on a single objective: track every move. Goldstone maintained radar locks. Webb ran continuous infrared scans. The European Space Agency scheduled emergency observing time on the Gaia telescope to refine astrometry. Even military satellites were quietly added to the watch list. Each new data point told the same story: approach speed steady, trajectory tightening, anomalies increasing. Whatever 3I/Atlas was, it was coming. And if projections held, Earth would witness its closest passage on October 21st, 2025, barely days away. September 29th, 2025. The first shift in trajectory is confirmed. Deep inside NASA's Jet Propulsion Laboratory, the neo-orbital desk logs a deviation measured in millimeters per second, small enough to escape casual notice, but unmistakable against the background of gravitational drift. 3I/Atlas is no longer coasting, it's steering. The update triggers an internal alert cascade. Webb's data stream is quarantined. The Minor Planet Center quietly amends Atlas's ephemeris to active anomaly. Within hours, every radar dish from Goldstone to Canberra pivots to a single target. The object's motion, once purely ballistic, now carries a vector offset directly toward the ecliptic, the orbital plane of Earth. At first, mission controllers assume outgassing jets or an internal vent, but radar return frames show no jet signatures, no plume scatter, no mass loss. Instead, the radar echo sharpens. The albedo, surface reflectivity, rises 12% in a single night. The effect mimics a polished metallic surface rotating under sunlight. That's when the tone in the control room changes from curiosity to caution. A closed briefing convenes at NASA HQ. Representatives from JPL, ESA, and the SETI Institute join a classified feed from the U.S. Space Command. They review a 72-hour projection model. 3I/Atlas's new course will carry it within 0.03 AU, just over 4.4 million kilometers, of Earth in mid-October. Inside that distance, planetary radar can paint its surface in real time. The operation is codenamed Project Aquila. Outside official channels, leaks ripple through astronomy forums. Amateur trackers comparing orbital datasets notice the update lag, the telltale sign of restricted data. Rumors spread fast. Atlas is accelerating. It's artificial. NASA's hiding something. Each speculation feeds the next until the story breaks mainstream. October 2nd. The Allen Telescope Array records a faint harmonic tone buried inside the solar wind band. It's not random noise, it's phase-locked to the same 4-hour pulse first detected in July. Analysts run a cross-correlation and find the signal has changed. The beat frequency now modulates every 20 minutes, as if syncing to an external clock. Whatever's inside Atlas is updating its rhythm. Meanwhile, the James Webb begins a new observation run, this time focusing on polarization, the way light scatters off a surface. The data return stuns the team. Polarization angles remain fixed across wavelengths, something that only flat or engineered panels would produce. The conclusion is unavoidable. Atlas isn't tumbling randomly, it's holding orientation, purposefully. At the European Space Agency, orbital analyst Marco Michelli refines the trajectory once more. His model predicts a gravitational slingshot around Earth, Not a collision, but a calculated skim through our planet's magnetotail, the vast plume of magnetic field stretching millions of kilometers into space. The pass would give Atlas a free velocity boost while sampling Earth's electromagnetic envelope. To some, it looks less like chance and more like reconnaissance. Then, on October 5th, the Solar and Heliospheric Observatory records a surge. Atlas brightens again, this time by 70%, and emits a flash of ultraviolet light invisible to the naked eye, but captured cleanly by satellite sensors. The burst lasts 17 seconds, long enough to ionize surrounding dust into a glowing blue corona. No known comet exhibits that wavelength profile. The UV signature matches the spectrum of xenon plasma, the same propellant used in deep space ion engines. The implication hits hard. If Atlas is venting xenon, it's not a comet at all. It's a vessel. NASA's Public Affairs Office issues a brief statement. Unusual activity consistent with volatile release, no risk to Earth. But behind closed doors, the Pentagon Space Command reclassifies Atlas under Defense Watch Level 2, one tier below active threat. Ground-based radar schedules switch to 24-hour rotation. Every ping, every echo, every thermal fluctuation is logged. As the object closes to 0.05 AU, the signal-to-noise ratio spikes. The 4-hour pulse fractures into subharmonics, 3 distinct beats overlapping like chords. Each subtone maps to a narrow frequency window in the microwave band, corresponding to 2.42, 4.84, and 9.68 gigahertz. Engineers notice a pattern. Double each value, and you get precise multiples of the hydrogen line at 1.42 gigahertz, the universal radio signature of intelligent communication. Across the Atlantic, the Meerkat array verifies the same harmonic ladder. Whatever Atlas is broadcasting, it's now transmitting on logical integer multiples of hydrogen's natural resonance. That's not cosmic background, that's intent. Public interest explodes. Headlines spin between alien probe and government hoax. But astronomers on the inside stay silent, bound by non-disclosure orders. Their only hint comes from an internal memo leaked to Scientific Monitor. Greater than object demonstrates controlled vectoring, less than consistent with self-propulsion. Recommend reclassification from NEO to AOV, Artificial Origin Vehicle. Within hours, the memo disappears from the site. October 8th. The blackout window begins. For 10 days, Earth's telescopes are blinded by the sun's glare, unable to watch the moment of closest approach. Radio contact falters as the solar corona floods the spectrum with charged noise. The world can do nothing but wait. But one instrument remains online. Parker Solar Probe trailing the inner orbit. Its onboard magnetometers record a shock wave, a narrow magnetic pulse passing the probe at 78 kilometers per second, matching Atlas's projected vector. Embedded in the waveform is a pattern, not natural plasma turbulence, but a repeating numeric ratio, 1 to 3 to 9 to 27. Powers of 3. Deliberate. When the data hits Earth hours later, half the scientific community calls it artifact, half calls it contact. The arguments rage, but the raw telemetry stands. 3i/Atlas just sent a mathematical fingerprint through the solar wind. Now the question isn't if it will pass Earth, it's why it's coming so close. October 15, 2025. The blackout window ends. The sun slips out of alignment, and for the first time in 10 days, telescopes can see again. The very first frame from the Goldstone radar array reveals something that no one was ready for. 3i/Atlas is not where the predictive models placed it. The deviation is precise, 0.002 astronomical units off course, small in cosmic terms, but enough to suggest an intentional correction. It has threaded the gap between Mars's orbit and Earth's like a needle through fabric. Goldstone's echo paints a shape, not the rough, jagged contour of a comet, but a smooth, elongated form. 170 meters long, 30 across, a flattened hull tapering to a luminous spine. The return intensity shows alternating bands, reflective and matte, exactly the pattern a controlled surface would create when rotating to manage heat. To the radar team, it looks engineered. By midday, the Deep Space Network triangulates a new path. Perigee in 36 hours, distance 4.3 million kilometers, close enough to fit within the Earth-Moon system on a single frame of sky. Every telescope that can move fast enough locks on. Then, the signal changes. The 4-hour heartbeat that had ruled every chart suddenly dissolves into a continuous carrier, a single unbroken tone stretching across the microwave spectrum. When decoded into amplitude plots, it reveals modulation, the first clear message-like structure. Not words, not images, but binary blocks arranged in Fibonacci sequences, 1, 1, 2, 3, 5, 8, 13, 21, a pattern universal to mathematics, biology, and orbital resonance alike. The meaning is unknown, but the intent is unmistakable. Inside the SETI Operations Center, computers translate the pattern into grayscale frames. The result appears abstract, rings nested inside rings, but when cross-referenced with orbital telemetry, the pattern maps perfectly onto Atlas's own trajectory around the Sun. It's as if the object is broadcasting its flight plan back to us, or perhaps reminding us we were already part of it. The following night, auroras bloom at latitudes far too low for normal geomagnetic storms. Chile, Egypt, Texas, green curtains rippling overhead. Magnetometers show synchronized pulses tied exactly to Atlas's transmission bursts. The planet's field is resonating like a bell struck by an unseen hammer. At 2:16 UTC on October 17th, the Hubble Space Telescope catches a frame that freezes every screen in mission control. A flare, sharp and deliberate, erupts from Atlas's leading edge, white-blue, coherent, laser-like. For 30 seconds, the beam points not at the Sun, but through the plane of the ecliptic, directly toward Earth's night-side hemisphere. The flash is harmless but unmistakable, a directed emission. Ground stations scramble. The beam's wavelength, 656.3 nanometers hydrogen alpha, is the same line long used in human astronomy to study stars. Some call it coincidence, others acknowledgement. When the light fades, Atlas begins to dim. Not fade away, but fold. Its signature compressing, its heat curve flattening, as though panels are closing or systems powering down. Over the next 6 hours, brightness drops by a factor of 10. Infrared imaging shows the object cooling rapidly, yet radar continues to track it. Still moving, still precise, but silent. NASA issues its final update. Greater than 3 E/Atlas will make its closest approach at 0422 UTC, passing safely beyond Earth's orbit. No hazards detected. Officially, the event is over, but the data tells a different story. Just after perigee, the L1 solar monitoring satellite DISCOVER detects a narrow magnetic pulse passing between it and Earth. Duration, 0.8 seconds. Energy density, off scale. The pulse carries a waveform nearly identical to Parker's earlier detection, the same 1:3:9:27 ratio, but reversed, as though echoing back the transmission we first received. The return path leads straight through Atlas's vector and out toward interstellar space. By October 20th, 3 I/Atlas is gone, outbound at 71 kilometers per second, fading into the black beyond Mars. Its last measured brightness hovers just above background noise, indistinguishable from a fragment of rock or a ship with its lights out. Then, silence. Weeks later, as astronomers sift through the terabytes of data, one anomaly keeps surfacing. A faint repeating code buried in the cosmic microwave background residuals captured during Atlas's flyby window. Each repeat occurs precisely every 4 hours, the old heartbeat, but shifted in frequency each time, as if moving further away. Spectral analysis translates the shift into distance markers. If extrapolated, the sequence points toward a region just outside the heliopause, the boundary of the Sun's magnetic influence. In other words, Atlas didn't just pass through, it left coordinates, a breadcrumb trail leading out of the solar system. Official agencies remain quiet. Press conferences return to the usual stories of exoplanets and atmospheric chemistry. But the private SETI networks keep listening. Every 4 hours, on the edge of the hydrogen line, a whisper returns. fainter each week, but mathematically perfect. It's as if something out there is waiting for us to answer. On the night of December 1st, 2025, a final unpublicized transmission arrives at the Canberra Deep Space Complex, just 3 pulses separated by long silences. When converted into audio, the tone sequence matches the same intervals used in early Voyager greeting messages. The waveform, when graphed, sketches a simple curve, a sine wave intersecting a circle, a spiral, the signature of orbital motion, or perhaps an invitation to follow. 3i/Atlas is now officially cataloged as departed, but its legacy lingers in every frequency map and every sleepless conversation across observatories. Was it a natural relic or a probe that came close enough to see us then moved on? No one can prove it either way. What we know is this: something crossed our sky, pulsed with purpose, altered its path, and left behind a signal that refuses to fade. In the end, the only certainty is what the instruments recorded, etched forever into the data streams. Greater than a heartbeat in the dark, a course correction toward the sun, and a final transmission aimed directly at Earth. As if to say, we saw you.